All right, so let's say you're packing and you want to pack something in your in your bag and you found that dang it, it's too long. It will not fit. I've had this happen so many times. So, what's my next course of action if it doesn't fit the length of my bag? I try and fit it in diagonally. And then if I find it doesn't work there, then I try and put it from the lower corner of the bag to the upper corner of the bag. And that's fun. So any vaguely rectangular shape, the diagonal of that rectangular prism will be the longest length that you can fit in that rectangular prism or in that box. So today we're going to do something called the 3D Pythagorean Theorem, which helps us find out how long that diagonal length is. On our first example, that diagonal length is this little red line right here. So we want to find how long that is. I'm going to go ahead and call it x. So this is Pythagorean Theorem. I'm going to see if that x is part of a right triangle. And I'm kind of a little scared of all the stuff above the red line. There's a lot of lines over there, and I can't find a triangle very easily. But I do notice that this part right here is a triangle, and it doesn't really look like a right triangle, though. Hey, guys, maybe this isn't solvable with the Pythagorean theorem. Hold up. This is 3D. A three-dimensional box, all of these little sides here are perpendicular to the bottom, which, fun fact, this little line here is still part of the bottom. So this is a right angle. So I found myself a right triangle. And now I should be able to find the length of that long diagonal line. Let's go ahead and write our Pythagorean theorem, a squared plus b squared equals c squared. And then we're going to fill in the letters. I need my A and I need my B here. Okay. So my A squared is 6 squared. That's pretty easy. But this other side, I don't know what that is. There's no label next to it. And to keep from being confusing, I'm going to call this J for Job. You could call it whatever letter you want and just put that there. And c squared is obviously x squared. That's the one I really want to find at the end. So this looks a little unsolvable. I don't have j, but if I can find j, then I can find x, the diagonal of the box. There's a lot of letters in here, but hold on, be patient with me. Basically what I'm saying is I need to find the length of that bottom side there. So today's assignment has been now find the right triangle. Let's see if J is part of a different right triangle. So I notice that it's part of this other triangle here. And it doesn't look like a right triangle, but it does include one of the bottom corners of the box. And the bottom corners of the box, because it's a box, they're all right angles too. So that's a right angle. And that triangle, even though it doesn't look like it, is another right triangle. So let's set up this one. I'm going to have a squared plus b squared equals c squared. And that side j is across from the right angle, so it's going to be our c squared. And the other two sides actually have measurements. Woohoo, we can actually do something. I'm going to put those measurements in. Now, let's just solve for j squared. 8 squared is 64, and 24 squared is 576. And when I simplify those, I get a big number. Hang on, let me find out what that is for you. 64 plus 576 equals 640. Okay, I kind of want to find the length of J so I can put it in that other equation. So let's go ahead and take the square root of both sides so I can find j. So the square root of 640 is 25.298, so about 25.3. So there's my new length, and that's equal to j. Now I'm actually, I think we're good. We got 25.3 here. We're not done yet. We want to find x. So let's go over to our other equation and plug in what we found thus far. 6 squared is 36, and j squared is 25.3 squared. I don't know 25.3 squared off the top of my head. So let me go ahead and put that in. 25.3 times 25.3. I get 640.09. Wait a minute. It was this one right here, wasn't it? So we're going to put that as 640. And then 640 plus 36 is 676. And now I need to take the square root of both sides to find x. Hey, that took a while, but I think we're almost there. The square root of 676 equals 26. Whoa, that was cool. We got a whole number answer at the very end of all that work. Okay, so that was a lot of work, and I have this other example that I want to do, but I don't want to do all that work. Let's see if I can find a better way to do this. Let's look at this. This is where our original problem happened, right? Like we couldn't find what j was, and that was kind of holding us up. Well, if I look at this, I actually have, it's not that I need j, it's that I need j squared. And fun fact, we actually have a formula over here that gets us j squared. 8 squared plus 24 squared. So I did all of this solving. I don't think I really had to do that. I could really just put in 8 squared plus 24 squared in for j squared because that's what j squared equals. And then I don't have to do all this garbage over here. So let's do that. We're going to put in 6 squared was my first thing plus j squared. Here's the equation I wanted to solve for x, right? So let's put in 8 squared plus 24 squared in for j squared. And now I have this lovely little formula, and I can just solve for x squared. So 6 squared is 36. 8 squared is 64. 24 squared is 576 equals x squared. When I add all of those things together, I get 676, which, fun fact, is the same thing I took a square root of above. So now I've found a nifty little shortcut to be able to do everything. Now let's see if we can generalize this. When you look at 6, 8, and 24, what are those numbers? When I look up here, I notice that 6 is this number right here, 8 is this number right here, and 24 is what? So the diagonal of the box is it's just that squared equals all of the sides of the box squared. So let's go ahead. There's a little shortcut for this that we can write. We got 6 squared plus 8 squared plus 24 squared. So 6 and 8 and 24, that's the length, the width, and the height of the box. And then that will equal that long side over there. Over here, it's called d. So I'm going to call it d squared. So now it's basic. Or if you want, you could write it so it looks like the Pythagorean Theorem. A squared plus b squared plus c squared equals d squared. So it's like we just went into 3 dimensions. So instead of having 3 letters, we now have 4. Pretty easy. So now we can use that to figure out our other box. And I'm going to do that in another video so that this one isn't quite so horrendously long. But you can check into that number to do the shortcut way.